Alright, this is our introduction to fractions. And our goal for fractions is that we can represent fractions a few ways. We want to represent them pictorially, concretely, symbolically. So with stuff, with pictures, and with numbers. And then we also want to be able to perform operations with fractions. Before we can get into that, we're going to look at multiples and factors. That's where we're going to get started today. And I'm just going to make a note here, C 4.1 from your text, which is called factors and multiples. But let's make this our title, and we are going to take some notes today. Today's actually a pretty heavy kind of language day, just so we know where we're at. We can kind of get ourselves started together. The first piece of language I'm going to throw at you is the word multiple. And when you're thinking about a multiple, what you want to think about is any number and all the numbers you can make out of it, right? 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So these are all multiples of 2, right? Going this way along any one of these rows is a multiple of 2. So to maybe define that, this is going to be my little symbol I'm going to use for definition today. A multiple, and let's get this in our notes. A multiple is the product, so it means we're multiplying, of the given number and another whole number. The given number and another whole number. So we're going to use this idea, we're going to build on this idea, but you saw if we had two, the multiples were 4, 6, 8, 10. We could put in an example here if we're talking about 6. The multiples of 6 are just along this row, right? Has the multiples 6, 12, 18, and so on. Alright, that's the first idea. And we need that, again, to build into fractions. We also need that to build to the idea of least common multiple. You're going to see this, you're going to work with this a little bit today, and as we get into fractions, you want these ideas in the back of your mind. This is just kind of how numbers are put together. The least common multiple, now we want to talk about some different numbers and their multiples. So if we're looking at 6 and 8, we could again say that the multiples of 6 are 6, 12, 18, 24, 30, and so on. Multiples of 8 are 8, 16, 24, 32. So our least common multiple is really just that. It's the smallest multiple that they have in common. So 24 is the least common multiple of 6 and 8. Alright, just a few definitions to get us started here. Another thing we can do again with this idea, this multiplication table and the ideas based on it, is we can look at factors. And in this case, we're going to work the table a little differently. We're going to look at a number like 12. We see 12 a few places up here. So the factors of 12 are all the numbers that it divides into. So in that case, 6 and 2 are factors of 12. In this case over here, we see 12 there. It can be divided by 4 and we get 3. So 4 and 3 are factors of 12. Over here again, same thing. 4 and 3 are factors of 12. 2 and 6. So that's kind of one approach to factors, one look at factors. Another approach to factors that's going to help you out as you start thinking about fractions is building these factor trees. And you've seen these before. And now we're breaking up these numbers into all the numbers that make them up, right? So in this case, if we break up 6, we're putting these numbers here because 2 times 3 is 6. We're creating the factors of 6. We're putting these factors along here because 2 times 4 is 8, or 2 times 2 times 2 is 8. So these are factors of a number. And we're actually, so let's maybe just get a definition of factor here in our heads on our paper so we know what we're working with. Again, there's a symbol for definition. A factor is a number that divides the given number evenly without a remainder. So now again, you see, you look at our trees. 6, of course, 2 times 3. 6 can be divided by 2 and we get 3, or divided by 3 and we get 2. Divides into 2 and 3 evenly without a remainder. 8, similarly, divides into 2 times 2 times 2 without a remainder. So you're going to use this idea of factor. Again, I think if you have some examples in your notes, that'll help you out. So here we're showing, and actually let's maybe just write this another way. For example, the factors of 12 are all the numbers that 12 divides into. So 1, 2, 3, we can divide 12 by 4, we can divide 12 by 6, and itself are the factors of 12. Alright. One other comment I wanted to make here, when we do this, these numbers, when we're going as small as we can, there's a math word for that. We're going to throw another definition in here. These are prime factors. And prime factors, the definition is a number that has only 2 factors, 1 and itself. Alright, we've got multiples, we've got the least common multiple, which is kind of an extension of that, we've got factors, we've got some prime factors. One more thing we're going to do here with factors, and you've heard this before, is we're going to talk about the greatest common factor. The greatest common factor for a couple numbers. And now again, we're going to use our trees. So when we talk about the greatest common factor, we could talk about 6 and 8, right? So the factors of 6 are 2 times 3. The factors of 8, again, are 2 times 2 times 2. So the greatest common factor, in this case, is just 2. It's the biggest factor they have in common. But if we use some bigger numbers, 30 and 45, a better approach is to look at their factors, right? Before we figure out what they have in common, we'll look at their factors. I would factor this like this. I know 2 times 15 is 30. I bring my 2 down because I can't make that any smaller. And then 15 I can break down into 3 by 5. So again, along the bottom, I've got my prime factors, and that's my factor tree. So my factor tree for 45, I've got 5 times 9 equals 45. 5 I can't break down anymore, but 9 I can break down into 5 and 3 and 3. So along the bottom again, these are my prime factors. Now if I want the greatest common factor, I might look at this and think that it's just 5. But if I keep looking, they actually both have 3's in there as well. And you might have seen this already, but now I can pull these pieces out. 3 times 5 is 15. 3 times 5 is 15. So maybe 15 is a factor of 30 and 45. So if I try it, well, yeah, that works. 30 divided by 15 is 2. And 45 divided by 15 equals 3. So 15 is the greatest common factor of 30 and 45. That's one thing we see here, right? Because we broke it down, we divided those numbers up, we took the prime factors they have in common, and we found the number that they create. So 15 is the greatest common factor of 30 and 45. Another way to say that is that the product of all the common factors is the greatest common factor. So again, all the common factors, we're talking about these guys. The product, we're talking about multiplying them together, right? That's what the greatest common factor is. So here's a definition we want in our notes. Definition of greatest common factor. Here's a definition we want in our notes, just so we know what a factor is. You can stop and grab that if you haven't already. Prime factors we want in our notes. That's important. Least common multiple. Just an example there I think is good, right? Kind of show ourselves where that comes from. So you can stop and grab that if you haven't grabbed that already. And then multiple. That's an idea for our notes. So we're gonna do some work. We're gonna do some practice in a minute. Actually, I'm gonna give you a practice from a couple sections. So section. Well, sorry. This is gonna be your assignment. It's just to do some practice with these ideas, and that's why it's important to have some examples in your notes. So assignment from 4.1 pages are the questions in your text. Questions are 105 to 108. I'm going to say choose, they're pretty small questions there, so I'd actually like you to choose 9 of those. And then from 4.2 just kind of builds on the idea of fractions, and I think you'll remember they set up a couple examples for you. They also set up this. This is the important piece, is just to remember what a fraction looks like, right? It's something divided by something else. It's something out of something else. That's really all you need for 4.2, and 4.2 is nice because it's a focus on the visual stuff. So you take a look at a couple examples there, but the assignment there is from pages 110 to 112. And I think if you were to do this, well, you know what, I think if you were to choose 7 of those, you'd be good to go. So you've got a couple notes or definitions in your notes today, and you've got that.